Well, good morning, good afternoon, good evening, and good night. I know that we have attendees from pretty much around the globe here for what I feel is going to be a pretty exciting uh, topic today. We're talking about an ability for all of you that are interested in doing chairside restorations or that are doing it now and haven't found a solution to be able to deliver these restorations within a single hour. So I'm pretty excited to uh, have as our primary speaker, Dr. Armen Mirzayan, who's going to be talking to us from his experience on using the Amber Mill Direct block. And Dr. Mirzayan, many of you may know already, he's been around within the CEREC world. He is a co-founder of CERECDoctors.com and now the CEO of Cadre.com, a dental technology distribution company. So he brings a lot of experience in the field of what I would say 3D technology, the entire ecosystem from image acquisition all the way through the fabrication of these appliances. And in fact, today's discussion will walk you through that entire process so that you could have a good understanding of how you can incorporate what I would say is a game-changing restoration in the market. So with that, Dr. Mirzayan, why don't you kind of take over and lead us through what I feel is going to be an amazing presentation.
Thanks for that, Sal. Let's make sure everything's sharing okay. Can you see my screen?
Yes, we could see it here.
There we go. Stop that for a second. Yeah, thanks for that introduction. Very much appreciated. Thanks for having me on. A couple other things, since there are CE units provided for this, so we have to go through disclaimers. I am not paid for this presentation. However, I do have a vested interest in this material doing well. We own a distribution company where we sell intraoral scanners, CAD software, printers, and milling machines. I've used probably 6 or 7 different milling machines on Amber Mill and Amber Mill Direct over the last few years. Of course, Amber Mill Direct is pretty new, so a little bit shorter for that, maybe a month or two. But yes, people purchase products from us. They purchase these blocks from us, and you need to know that I have obvious an interest in this material. And let's get started with the presentation. So I thought it would be great. So I love the topic. I love the title for this presentation. So I thought I would take you through the whole process of acquiring images, digitizing models, whether they're impressions or intraoral scans, how the design process works, how the CAM software, the nesting works. We probably won't spend much time on that. It's kind of boring. And then we have the manufacturing process that you should be very well aware of. Because these materials are very intricate. You need to handle them very, very properly and nicely. So there's a couple of ways you acquire or you render 3D models. So you can scan patients intraorally with numerous different intraoral scanners, and you can also um, digitize models by using a tabletop scanner. So these tabletop scanners that the labs use are very well known to be very accurate. So if your impression is accurate, if your stone model is accurate, you 3D scan it with a desktop scanner that render 3D models very accurate. So you can acquire these images of a bunch of different ways to render your models. And then you can also incorporate a CT scan that's digitized. So you can merge your CT scan, you can merge your intraoral scan, you can merge your desktop scan. And then when you take all this information, all this raw data to the CAD software, the CAD software no longer cares where you acquire these images. So the reason I'm emphasizing this is 10 years ago, I overspent by quite a lot, well over 6 figures, trying to buy an ecosystem because that's all that existed. So I would have to buy one manufacturer's scanner, one manufacturer's milling machine, one manufacturer's CT machine, and hope that they all integrate seamlessly. Well, fast forward to today, it just doesn't matter. You can use any intraoral scanner, you can use any desktop scanner, you can use any CT machine, and all you need to do is capture the data out of those machines and then take it to design software. This stands to save you quite a bit of money. And as long as you understand how this workflow works, then you can pace yourself and integrate these technologies so you can manufacture Amber Mill restorations in your office, chairside, or in your lab. So once you get to the CAD, it's a CAD software. It no longer cares how you acquire these images. So very empowering for a dentist to be able to function this way. 'Cause like I mentioned previously, we'd have to really overspend to be able to accomplish this task. And then from there, you take that material, you take the designed restoration to CAM software, and the CAM software, to keep it simple, calculates how you're going to carve out this restoration. There's a lot of nuances, a lot of details there. You want to make sure that the restoration is thick enough. 0.3 millimeters, 300 microns is safe. So anything below that, you generally have to bulk out, protect the restoration while it's milling so it doesn't shatter on you or chip on you, like the Victoria is for. So it's a lot goes with the CAM process. And then from there, once you have designed or you have nested the restoration, then you manufacture. You can mill restorations, you can print restorations, you can print surgical stents, you can print night guards, you can mill all those things. So the world opens up to you in terms of all the possibilities. Now, some dentists, their personalities are that he or she doesn't want to do anything past the image acquisition. They have no interest in designing things. But it's very empowering when, as a clinician, you mark your own margins, you do your own design, you have complete control over the outcome. Contacts are perfect, margins are flawless. So there's a fine balance, and I highly encourage every dentist to minimally mark their margin or get into designs, and then that'll open up the floodgates for you to get into manufacturing if you're nowhere near that stage yet. So they can take advantage of that. So now let's move on. One other thing to tie it. So my job, I'm the educator at Cadre. So my job is to make sure people understand how not to introduce errors at every one of these steps. You can certainly introduce errors when you're acquiring control scans. You can introduce errors when you're acquiring CT images. You can introduce errors when you're designing this, and you can definitely introduce errors when you're milling them. So now let's spend a little bit of time on the far end of this graph, which is the manufacturing part, which is milling machines. So milling machines generally, they just do what they're told. So here you can see how restoration is broken off the milling machine, but the milling machine continues to mill. It's only a third of the way through, but you can't tell. And of course, you can buy higher end machines that have sensors that can tell you, hey, the tool is broken, hey, the block is broken. But generally, you go by the sound. You're so used to when the burr is dulled, it makes a different sound if you've been at it for a while. So we've tested over 11 milling machines for a chairside operation, and they all have the same issues. Excuse me for a second. They all have the same issues. So here, what you're seeing on the far left is a Cirac milling machine that's shooting water from the sides. Here's a milling machine that mills from the top. And if you don't get that water perfectly on the tool, if you're off by a millimeter in any direction, then this happens. You can see flames being thrown off different materials. It's just not lubricated enough. And the faster you go, the more strain on the tool, the more strain on the block. So you start breaking things left and right. So let me slow down a little bit here. I feel like I'm talking too fast. So let's go back one step. So these glass ceramics, these amber mills, amber mill direct, other lithium disilicates, it's very simple. Let's say you have an air-driven handpiece and you have a electric handpiece. Well, the one with the torque, higher torque, can accomplish a lot more, much more quickly. But if you turn the water off for both handpieces, it doesn't matter. They're both dull out real fast. Within seconds, they hit the two structure, the diamond rips off. You're on the carbide now. You see sparks flying, and it just no longer cuts anymore. So irrigation is very, very important. Once you turn on the irrigation, then your high speed, high torque electric handpiece can certainly outperform the air driven. Without water, they both perform poorly. So the faster you go, the more copious amounts of irrigation you need. And generally, I'm a dentist, a chairside dentist. We want it fast. We want it now. We don't have the patience to wait for 30 minutes for a restoration of mill. So we want it down for molars to under 15 minutes, premolars to under 10 minutes. Those are the benchmarks. And then with zirconia, you don't even need water. It's dry milling generally. You can mill that in under 5-10 minutes time, depending on the size of the restoration. So copious amounts of water are very, very important. And so I'm breaking burrs left and right. I'm trying to push all these milling machines to render faster restorations. Here's yet another one. So this is slow down a little bit for you to understand. So the Cirac one, that's the benchmark that everyone compares to, mills from the sides. Just by virtue of this axis, there's enough water shooting at the block to keep it cool. These other mills that mill from above, well, you may have enough water hitting the top, or I should say the bottom part of the tool or the burr, But the tip of it, that's doing a lot of the work, can just, for in a split second, dry mill, and then the whole operation is shot. Your ceramic breaks, your amber mill breaks, your tool breaks, and you're very, very frustrated. Okay, so here's another milling machine. This one is shooting water or irrigation from below, and you can see how little water is being displayed. So this machine didn't actually even make it to market because I assume there's just not enough irrigation or enough lubricant to keep the restoration protected. So now we get into these milling machines where I'm adding supplemental water. So here I've added a geyser to the equation to make sure that the restoration is always cooled from below. At one point, I put a water tank from a fish tank to make sure I have supplemental water to cool these amber mill restorations or keep them lubricated, so I can get a lot more life out of it. Ultimately, what happened is this one particular company developed this water bath. So now you're seeing the Amber Mill Direct soaked and submerged. And ever since we were able to do this, ever since we are able to bury the whole restoration or the whole block in water and have the machining happen under copious amounts of water under submerged conditions, our tool lives dramatically improved. The number of broken restorations, you still get them if you don't calculate correctly. But the amount of wear and things that you see on the diamond, the damage to the restoration dramatically reduced. So very, very importantly, understand this. When you're milling Amber Mill Direct, Amber Mill itself, you have to balance your needs for speed and making sure that it's well lubricated. You can go very, very fast as long as it's submerged. Whereas if you have a different milling machine where you don't have this option for submerging the restoration, you have to go slow to protect the material. So it's a fine balance always in a dental office to make sure you're going fast enough to meet your needs for the day, but not to strain the materials. And submerging them makes a very big difference. So really happy to report on that and our findings there. So we're constantly testing stuff. I've got multiple milling machines, so I've been using a lot of these Amber Mill Directs, testing them, see how they turn out, how they fit, and we're constantly putting through a lot of different routines here to see how they perform. So I thought I would take you through this one particular case, two cases I want to take you through. First one is with Amber Mill. The thing that I like about Amber Mill, I've been using for maybe 3 or 4 years. I can't recall exactly when I started using them, but it's been a while now. The thing I like about lithium disilicate in general versus zirconia is I've been milling chairside for 20 years, and there's one step I never skip, which is the try it. I'm usually more OCD about that. I want to make sure I have no issues. So while seating the restoration, I want to make sure I don't have any weak contacts. So for me, there's a nice stopgap. I build it. I like to try in the restoration. I like to check the contacts. I like to make sure there's no mishaps. And then I put it in the oven and crystallize it. Crystallizing is very different than sintering. Sintering is for zirconia, different oven, different temperatures, works very differently. And generally, you overbuild the zirconia, and then when you sinter it, it shrinks by a third. Whereas amber mill, lithium disilicate material, they're proportionally dimensionally the same. They don't change shape unless you don't support it well in the oven. That's a whole different tangent. So now this second molar case, you'll see an open margin. There's a distal lingual cusp that's broken off. So we're going to replace this. So I thought I would take you through the whole clinical presentation of how we do this, particularly because the topic of or the title of the presentation is how to restore these chairside with CAD/CAM technology. So one of the biggest keys for using any kind of technology, whether it's milling, printing, scanning, is you want to delegate as much of this as possible to your team members. So what you're seeing here is a dental assistant. She is scanning the second molar that's has the distal lingual cusp broken off. If you're not familiar with intraoral scanning, or if you're not familiar with this particular scanner, the Method scanner, you'll see how I'm scanning the blue box that's highlighted in the top center of your screen. That is the pre-op situation. So right now, the assistant is scanning the pre-existing condition. So even though that restoration is broken off at the distal lingual, looks like it was too thin, we still have 2 or 3 cusps that I want to incorporate into the design. So whether you design this yourself or you're sending this to the lab, you can incorporate those other cusp tips in the new design of an exact match of the pre-existing situation. And what that means is when you deliver the restoration, the patient's not going to complain that it feels bulkier, it feels different in contour than what they had in their mouth. So anytime I have an existing tooth structure, I always try and scan that to incorporate into the amber mill after it's been designed and built. So now we're going to move to taking images of the opposing. And second molars with CAD-CAM, I'm very annoyed when I have to adjust second molars. So one of the greatest benefits to CAD-CAM is the control that you have. So you can see exactly how much reduction you have, and you can have design the proper restoration. So when I deliver it, I have very little work to do in terms of adjusting it to the patient's mouth. So what you're seeing here, the red dots are articulation marks that the articulating paper has left. And what I do is I generally watch to make sure that my clinical occlusal stance match the digital proposal. So that's what I know. I captured the bite correctly. That's why I know the patient hasn't opened inadvertently. I know the vertical hasn't changed between the pre-op and the post-op. In fact, that's exactly what I'm going to do. So I took the pre-op scan. I took the upper jaw scan. Now we'll move to the bite scan. So we're taking the bite before we prep it. So always do this. Every distal extension case, every second molar case, I take 2 scans. One scan is for the pre-op condition. One scan is the post-op condition. So here what you're seeing is she's scanning the bite with the second molar not being prepared at all just yet. So now this turns green, and that was the first bite that I took. And when I take the bite again, the second time around after the second molar is prepped, I'm going to make sure these 2 bites match each other because I don't like to adjust second molars, and I want to be able to seat this Armen direct and not worry about any adjustments. So always make sure I take 2 bites. Now I'll travel back to the top of the screen. This is called image catalogs. We'll go ahead and click on the lower jaw scan. That copies everything over from the pre-op scan onto the prep scan. And then the assistant will crop out this tooth that's going to be prepared so that I can remove the crown, modify the margins, remove the decay, and then image just the preparation. So very important to understand this. The assistant took me posing. They took the bites. They set the stage for me. And all I got to do is when I see the patient, I've got to prepare the tooth, get hemostasis, retraction, and then we'll go ahead to scanning, which is what you're seeing here now. I also pack 2 cords, or I'll pack a size 2 cord, so that I get good retraction, good hemostasis. And I'm using a product called Isolite to retract the tissue. And the main reason you're seeing this big fat yellow size 2 cord is the cord stays intraorally, stays wrapped around the tooth until I deliver the restoration. So as it's being milled, as it's being fired, if I do fire it, if I'm using Armen Drect, the cord stays there the whole time. I'll bond the restoration, and then when I go take the cord out so there's no debris left in the sulcus, the size 2 cord doesn't tear. Anything smaller than that, when you go to take it out, it may tear, and now you got a bigger problem. You've left some debris behind that you have to go clean up. So size 2 cord helps tremendously. I can get very aggressive with flossing, clean up as everything's setting, and at the very end, I will remove that restoration. So now we're back to the buccal bite scan. And if you remember, I took that first scan while the pre-op condition was present. Now I'm going to take the second scan for the bite. And as soon as it turns green, I know that I've captured the bite correctly, or I should say it represents the exact same way the bite was captured in the pre-op. So both of these bites are green. It's a great indication to me that the patient hasn't moved, the vertical hasn't changed. There's no issues. My pre-op vertical dimension matches my prep vertical dimension. I'm ready to go. So every distal extension case, I take 2 bites. It saves me from a lot of headache, saves me from a lot of adjusting. So now we'll proceed with designing that and manufacturing. So now this is a different case. That was just a case setup. And now we're going to follow through with finishing a second molar. The first thing I want to point out to you is that retromolar pad tissue that's by the second molar. This isolite that you see in the patient's mouth and the Optrogate make it really stress-free for you and your team to capture that second molar. And what I'm doing now is I'm taking that camera and I'm driving it to the back of the mouth. This takes all the tissue off the second molar distal margin, peels the tissue off, displaces it so they can capture all the margins. So here's what you see with the scanner software. As soon as you turn it on, we want to be able to see the margins. And what I'm looking at, actually, seasoned user, we look at the live view on the right side. When the center of the screen, that's called a preview, and doesn't have the greatest resolution yet, hasn't been processed yet. So clinically, when I'm scanning, I'm looking at my margins in the live view in the bottom right window. And if I can see my margins in that view, then I'm pretty confident that once the models are rendered, I'll be able to see those margins. Okay, so let's go take a look at this. What I'm going to do is I'm going to locally process this case, and I'm going to mark my margins, and then we'll show you the CAD software. So far I've shown you information on scanning. I've shown you information on manufacturing. Now we're going to go a little bit of time on the CAD software so you can see how easy it is to design for these Armen direct restorations. So here's the preparation. Excuse me, I have a sore throat. So now we locally process the second molar, and we're going to mark the margins. So a lot of scanners allow you to delineate where your margins are. And when this is blown up 50-fold, it's very humbling to see your preparations blown up like that. But on the flip side, it's great because it lets you anticipate any problems you may have with the bite, the marginal fit. Do you have good butt margins, shoulder margins, so that you can manufacture that restoration to a nice shoulder margin. Deep chamfers are always tricky for milling. You always bulk things out and make sure it's protected, like I mentioned before. But this is a great way for you and your team to see exactly where your margins are. We are now fine-tuning so much detail that's actually impossible for me to actually manufacture anything to that great of a resolution or that great of a detail. So this step's pretty important. And now what we're going to do is we're going to go to the next step, which is the CAD software. So here I'm using our software. This is a program we have built called Clinics, C-L-I-U-N-X. It is called a Clinical User Experience. That's where it's derived from. And the margin comes through once you, after you you place the margin. You can modify it if need be. There was no need there. That was just a little demo. Now we're setting the path of draw. And the main reason I want you to see this, and I know there's a wide range of user experience here with digital technology. What I'm doing here is I'm going to delineate the pre-op condition. This is what I meant about that copy, the pre-op. I am circumscribing everything I want the software to replicate or copy. And if there was a broken custip here, I would exclude it. If there's any kind of condition I want to keep, I'll delineate it with the orange line, yellow line. It's incorporated in there. So it's called a copy mode. Biogeneric copy is another common term from CIRAC days. But it's very simple. You're just telling the software, you're telling your designer, whether it's you in-house or a lab, I want you to copy as much of the pre-op as possible. Very beneficial, very easy design. Now we'll go ahead and we'll touch up some contacts, contours. And this is probably one of your biggest arguments for getting into manufacturing these restorations yourself, is the fine control you have over how heavy you want your contacts, how broad do you want them. You can add some morphology to this if you want. So you can make a nice broad contact. So the control is probably the most appealing part of the whole process for a doctor and his or her team, to be able to just check the occlusion perfectly, be able to have the perfect contacts and a great marginal fit. So now this goes into the milling machine and you're ready to fabricate the restoration. So this first case I'm showing you is amber mill. I sped up the video a little bit. It's transparent, transparent when you try it in. So I'm checking my margins. I'm checking to see that my contacts are great. And this is a really important step for me. If my contacts are weak, it's extremely easy for me to add a contact in the oven while it's glazing. So this first case, the second molar one that we're seeing here, now it's been crystallized. You saw it change color. Amber mill, we'll spend a little bit of time on materials. Amber mill, you control the translucency with the temperature settings and how long you cook it for, to keep it simple. So you can have HD, LT, MO, and all of those has indications in terms of how long you place them in the oven. And here's what I meant with this, using the cord to block any material from going down to the sulcus, making things difficult for you to clean up. And we're able to remove the cord, modify or clean up anything that may be into the sulcus or in the contact area, floss it out at the very end, take the cord out, and then I check the bite and make sure that everything's to our liking. So that's the second molar that we replaced with Amber Mill Direct, checking the bite. Like I said, I don't like to do any adjustments on second molars. I find it cumbersome, so I'm always making sure that I've taken everything into account to make sure that very little work to do after it's been removed. I do like to take final x-rays to make sure that there's no excess resin. Of course, I like to document that it's seated all the way, so I'm always taking a peek while the assistant's trying to scan. Excuse me, while the assistant's trying to take an x-ray to make sure that we have no leftover debris and my margins are closed and can document that we delivered the case. Lastly, let's take you through an amber mill direct. So this is pretty exciting because it removes the step where the oven's involved. So I thought I would share this case with you. This is a scan, and we're showing you all the different types of ways you can see these models. And the main thing I want to draw your attention to is this finish line of this onlay preparation. And the whole reason I chose this because I want to show you exactly how this restoration looks after it's been milled when I'm trying it in. Let's go to the next step here, and that's after it's manufactured. This is what I was trying to get to. So if you look at that onlay in the top left part of the image, I have not bonded that in yet. I just wanted you to see exactly how well it's milled, and you can see how the margins are very crisp. Out of everything I've milled, the Amber Mill Direct, Amber Mill itself, extremely kind to the margins. Perhaps in the Q&A section or following up on this, we'll have these issues addressed, or we can find out exactly what it is, what's the component of this material, what's the filler material, what's it utilizing to have the margins so well protected and crisp without any chipping. So other lithium disilicate I've used, blue blocks I've used. If you're not careful, you get a lot of chipping at the margins, particularly on onlay preps like this that come up a cable surface wall. And here you see one that's just been polished. You can see how the marginal integrity, how nicely it looks. It's not chipped. It's very congruent. It's very much intact. And once you seed it and then deliver the restoration, just blends in with the two structure. So that's pretty much a great overview I wanted to give with regards to my presentation. So I took you through imaging. So obviously these are, we can go into every one of these topics for days material information, but I took you through the whole process. I took you through imaging, I took you through design, I took you through manufacturing, I took you through delivery of the restoration, and a good time for Mr. Sal Rodas to come back on. Hopefully I pronounced your last name correctly, Sal. That we can discuss some other things about the material, the chief differences when I use Amber Mill, when I use Amber Mill Direct. Not having to deal with an oven is great. Here's what it comes down to. Again, like I said, I've been doing this for 20 years. I'd stain and glaze all my restorations. I'd deliver them. I'd take photos. I'd show them to patients. And then when they'd see any yellow or brown, all the colors make the anatomy and things pop up when you stain and glaze the restorations. But patients, I found over many years, all they care about is smooth and white. So generally, we stain and glaze just so it looks good to other dentists and we can please ourselves in our eyes. But patients, all they want is smooth. All they want is white. They don't like stains in the grooves. Oftentimes, when I do the stain and glaze, I'll deliver it. I have to go back and brush off remove the stains that I put in there. So for the vast majority of the population, just polishing and delivering the restoration with no overtime is extremely appealing. You can crystallize these Amber Direct restorations, and the temperature settings will also affect the outcome and the color. So I'll stop sharing the screen, give Sal a chance to jump back on and see if he has any questions, if he has any material he'd like to present. I think you do have some slides you want to show with regards to the properties of the material, so I'll let you take over. Is there anything I need to do? Yeah, I did stop sharing, so you are on now.
Thank you very much, Doc. And yeah, let me share my screen here. First of all, I want to highlight, how smooth of a presentation you gave, despite, being early in the morning and being a little bit under the weather. And unless I said it, I guess no one else would know about it. But, I think you highlighted some very specific properties of what the Amber Mill Direct product does for practices that are looking to achieve, again, that 1 hour restoration. And you highlighted some of the features specific to the smooth margins that you could achieve with the product. So what I wanted to detail a little bit more about our product, why Amber Mill Direct should be considered in a practice I think you've already highlighted, it's not only a simple restoration to use in comparison to others, but it's also durable. And the ability to have uh, the 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 product packed in a way that it could give you different strengths, whether you're on the incisal or the cervical side of the product, is another one of these other unique features of Amber Mill Direct that I'm going to highlight, which you could see here on the functional gradation of the product. We recently had an independent research done by Dental Advisors, where the average megapixels for the product are approximately 349 MPa. And as you could see on the image on the left here, the cervical and the incisal microstructures are different, which again is a unique feature of this product. It's going to give those smooth margins, and it's also going to provide you with a great experience for the opposing teeth when placed. So, Dr. Armen, since you're on the line here, and I know you talked about it, but why do you feel that the product performs so well in the different settings that you have used it? And I know that we're talking about Amber Mill Direct, but I think that you have achieved similar results with the Amber Mill as well. Can you just talk a little bit more about that and why you feel that the gradated feature of this product is of benefit to you and other practitioners?
Absolutely. I mean, I'm not a materials expert. Quite honestly, Sal, I don't even understand exactly what the significance of this is. All I know is, as a practicing clinician, I just see the end result, and I've milled thousands upon thousands of restorations. The Emax restorations are notorious for chipping around the margins, so we always had to bulk them out. And now the legacy of Amber Mill, I mean, that's what gave me the confidence to go with Amber Mill Direct, is that I saw multiple restorations with great finishes, great margins, no chipping, no ditching. And I assume it's all those material components that you're discussing and the fillers that you're mentioning here that lead to that result. So to me, all that matters is that finished result. Is it strong enough, and does it mill very well? Is there any concerns with the chipping and ditching? And it's worked out remarkably well. Like, this is all I use exclusively now.
Great. And moving onward, then again, talking about that edge stability, this again is one of those unique features of our product. And as you could see here, you're able to achieve less chipping, as Dr. Armen just mentioned. And again, that's going to give you these beautiful margins that are hard to achieve, I would say, with many other products in the industry. And in addition to that, the other advantage of our product is that the wear resistance and the fracture strength of our product is going to be providing you with a durable end product, which is always a concern, right? How is this product going to compare to others that have been around for some time in the market, and will it survive its intended longevity? And again, to that point, Dr. Armen, I think you have used our products for quite some time, and you have seen that these products last as you would expect from any other product at this level of proficiency, correct? And I don't know.
Oh, I was muted. I just
Yeah.
said I'm very comfortable agreeing with that, validating that as a very fair statement.
And again, this goes on to show the cutting force of the product. And for all of the attendees, you'll have access to our product brochure that's going to dive into more technical details about the product, how the product has an ability to achieve excellent translucency and opalescence. And ultimately, the goal is to provide you with a simplified workflow, the ability to take a product that you could mill, and then you have the option of simply polishing and then delivering to the patient, but it doesn't end there. If you want, you could also mill it and then stain and glaze to your pleasure. And if necessary, you could also change the translucency of the product from HT to LT if you want to bake it at over 840 degrees Celsius. So again, it's a product that's very versatile, and it gives you abilities that other products in the industry are not able to achieve. And this is why we're so excited about the product. So again, the workflow that Dr. Armen, you showcased today very well are these simple steps, right? You scan, you acquire the image, you then design your restoration, you nest it, you mill it with the milling machine, and at that point, you go through your next steps of removing the sprue, and you could either polish, stain, and glaze, which is optional, as you could see there, and then you cement the product. So very simple workflow. Again, keeping in mind that in some cases, practitioners are interested in being able to get patients fully out of the office with that crown within 1 hour. And here are additional clinical cases that I want to showcase. In this case, we have a colleague, Dr. Yaoling Tang, showing the Amber Mill Drect. And another case here, in this case, courtesy of Christian Petri. Again, beautiful outcomes. And the Amber Mill Drect comes in these shades, and for the various indications, as you could see here, inlays, onlays, veneers, anterior crowns, and posterior crowns. So for all of the attendees that are watching this presentation, I invite all of you to go to tryambermill.com/DTI, enter your information, and we'll send you trial packs of the Amber Mill Drect so that you could try them in your hands and then have an ability to try out the product for yourself and give us your feedback as to how well the product is working in your hands. So with that, what I'm going to do right now is just change over real quick so we could see what kind of questions we have for you, Dr. Armen. And I'm going to stop the share here so we could see what questions have come in. Okay, so here we have a question. I would like to ask if it's worth for someone to buy this whole system. And the reason is if within an hour and a half, you can provide the services that the companies that sell these devices promise. So that's a question, Doc. I think that speaks to the entire system and if it's well worth the investment.
Very, very much a loaded question. How much time do you have? I've got some great answers. So here's how I describe it. I'm a dentist. My wife is a dentist. I'm in a dental office all day long, most of the week, and I don't have time for the dentist. I don't have time to come back for a second appointment. I don't like getting blocks. That's not fun. I've actually had a full mouth rehab done. Every tooth in my mouth 15 years ago is a lithium disilicate material. So from that perspective, finishing a restoration in 1 hour's time, I do this all the time. It's very practical. It's not for everyone. You need to be really engaged in scanning, designing, milling. But once you get going, it's very simple. So a lower premolar I can do in under an hour's time, particularly when there's no oven involved. An upper second molar takes me at least an hour and a half. And generally, I'm never doing a single restoration at any one time. So even though you may do one crown, I generally have an opposing filling or a couple of fillings next to the crown, whatever it is. So you always leverage your mill time with doing something more productive, hygiene check, whatever. You don't sit there and watch it mill. You do something more productive. So you're not just doing the crown generally, you're producing a lot in conjunction with handling the crown. So there's a tremendous benefit. In some parts of the world, I have no idea how this would work, but in the U.S., we make this much at the office. We spend this much at the office. The difference is the profit. You're taxed on that. Well, on top of that, we have depreciation. So that shrinks the amount of your tax liability. So you have a lot of incentive instead of having a lab bill that you just send to the lab. When you have a device in your office, you're a manufacturing thing, there are tremendous tax benefits in a business code for you to utilize that kind of machinery. That's not enough good reason for you to invest in technology. The tax benefits, all those come in secondary. You just have to be convinced they can deliver high quality care in a shorter period amount of time. And the number of times we've all seen this, we have a patient that's in the hygienist chair. They come in, there's a broken tooth, and you say, well, you're here. Might as well let's get this procedure done, move it to the operatory column and render a restoration method. So this opens up a lot of avenues for you. Not dealing with the temporaries are great. Um, the main reason I like glass over zirconia is I do a lot of non-traditional preps. If I was using zirconia, I got to make sure I got my 3-4 millimeters wall, great resistance retention form. But with bonding to glass and lithium disilicate material, I can be very non-conventional with my preps. I can do onlay preps, crown lay type of preps. I can blend the margins to hide them in very nicely. So there's a lot of tremendous benefits to exploring this, and also the cost now for doing all this is exactly why I started with the very first slide, where you image, you design, you mill. You were looking at 160 grand a few years ago. You're looking at under 60 grand now with all the different options available to you between scanners. Scanners 10 to 15 grand, milling machine 20 to 30 grand, closer to 30 grand. So you can absolutely do this for a shoestring budget now, whereas just a few years back you had to really invest in systems that were well established that would cost quite a bit. Hopefully, I wasn't on mute that whole time. Could you hear the whole thing, Sal? No, it's not on mute.
Yes, we did hear you. And to the subject of image acquisition, in fact, we do have a question here saying, do you have a preference for specific scan files? And then question says, what machine, what brand name? This is question that came in on the subject of imaging.
Great question. So that's also quite broad. So I've used multiple scanners. Again, for full disclosure, we sell scanners. We sell the Medits. We're the world's largest Medit distributor. We sell the 3Shape scanner. We have quite a few scanners, and it's very simple. It's the hardest question for me to answer when people ask me which one is the most accurate scanner. That is an impossible question to answer because I can give you the most accurate scanner, quote unquote, and then the very next scan that you do, you introduce errors, and you don't know why you introduce errors. So it's not foolproof. The clinician who uses the scanner is in charge of making sure they acquire accurate scans. You can get an accurate scan with every intraoral scanner on the market. Now, the other way we explain this is you have the Trio scanner, which I love right now. That's driving a very nice luxury car, just delivers great performance. But we have other scanners that I can take you from A to Z. You'll get there, you'll have the same end result, maybe slower, not as smooth an experience or as great an experience as the Trio. So the Trios is, especially the Trios 5 now, it's definitely set itself apart from other scanners. So I use that quite a bit, and I use a Medit scanner quite a bit. And then in terms of which files you want, all these scanners can render, actually the Trios can render PLY and STL files. Medit can render OBJ, PLY, and STL. OBJ and PLY are color models. I only work on color models. I can find my margins very readily. If I have a dark blue or a green cord around my margins pop. Whereas most labs, what they prefer to do is work on the monochromatic model, the STL model. They like to look for two-plane reduction. They like to use the STL file. I don't use that at all because I get so much more information from a color file. But most lab technicians, their preference, their training was on monochromatic blocks, monochromatic models. So that's what they prefer. Was that a good answer, Sal? Did that satisfy the person?
I think so. I think so. Yes, I hope so. And the other question here is now on the margins. What is the expected marginal gap when using this product? Is that something that you could address there, Doc?
Yeah, adhesive gap. What do you mean by marginal gaps? So you have in your CAD software, you have complete control over the cement spacer. You have complete control over how much adhesive gap you have. But at the margins, that's usually sealed and closed. And then usually, like in exocad software, you can decide where you want the adhesive gap, the cement gap to start. So some people will take that adhesive gap very flush to the margin. I actually have mine starting at about a millimeter away from the margin. Maybe perhaps I could share, I can share a simple X-ray, so you can see uh, exactly what we mean. Hang on one second. You can see the spacer.
Okay, while you do that, Doc, the attendees are asking for the link to try out our product. The link is tryambermill.com/DTI. And we're also going to share it. Razvan, if you could share it with the attendees, that would be great.
Can you see my screen now?
Yes, Doc.
Okay, so let's go to this particular slide. Okay, so for the adhesive gap question, if you look at this premolar here, you can see how this white opaque is the resin cement line. Let's go to a lower one, maybe. Let's find a better one here. Let's go to the anterior. Yeah. So when somebody asks about the adhesive gap, you have complete control. Actually, this may be the best one to demonstrate. So here's the margin ends up there on a millimeter away. This is where the adhesive gap starts from. So every part of this equation in your CAD software you have control. You can decide where the adhesive gap starts. You can decide how thick the adhesive gap is. All those play a big role. Generally, your adhesive gap, your resin cements. I'm not an expert in this, but just regurgitating what I've heard in the past. You want about 80 to 120 micron cement spacer. That's when the resin cements are their strongest. They're weaker at less than that. They're weaker at greater than that. So that's the sweet spot you're looking at, is about 80 to 120 microns of adhesive gap. So Sal, you have to let me know if that was a satisfactory answer to your question.
We'll follow up as well with the attendees to give them a more technical answer, because in this case, that would be outside of my expertise as well. But I will move on to the next question, which is when curing, how forgiving is the product compared to, when you compare lithium silicate and conventional zirconia? Is that something that you could address, Doc? What is
Yeah.
the level of forgiveness with our product?
Well, for one, you can't cure the zirconia, right? Usually cure just around the margins, but usually you have to wait for the light doesn't penetrate all the way through with the zirconia, whereas with the lithium disilicate, you can cure all the way through. So usually use dual cure resin cements for if you're going to be bonding zirconia. Actually, I don't use much zirconia simply because I can bond to it as well. Over the years, the bonding techniques and things have gotten much better to zirconia, but that's the whole beauty with the Amber Mill products, is you can cure all the way through and reach your cement layer.
Okay, another question, which I think you may have addressed earlier. Any advice on the cost of the devices? I think you did mention some pricing, but just general. And I think it should be noted that we're speaking from the perspective of the U.S. Some of these prices will range differently outside of the United States. To what degree those prices change, I don't know personally. Maybe Doc, you might know a little bit better. But if you could just give again a brief overview of what does it take for someone interested in getting into chairside dentistry, from the imaging aspect of things all the way through the process of the milling machine.
Sure. We're very open. Our prices are published on our site. Sal, can you see my screen? Just make sure everything's
Yes.
displayed. Okay. I mean, literally, you can go create yourself a cart, and answer all your questions. So you can go to the Trios wireless section. You can see what the price is for the Trios scanner. You can add that to your cart. You can go back and then see where the milling machines start from. So everything's spelled out for you, all the different scanners. There's printers, lasers, CAD software. We have so you have quite a few CAD options. You have ExoCAD option. You have 3Shape options. We sell all of those. We're distributors for those. We have our own software called Clinic, CLA, and UX. We include those when you buy a scanner or a milling machine. It helps you design single units. This is all web-based. It's a browser-based program. We've developed that at Cadre, and then you have these milling options. So you have this is probably the one that I've milled the Amber mill the most with this the DOF 5-axis mill, and also the Chairman I've used quite a bit to test your material as well. So you have quite a few milling options. They all have their pros and cons. The 5-axis one can mill abutments, the zirconias, amber mills, submerged, dry mill, wet mill. So it all depends on the amount of volume that you do. If you are like this, Roland, actually, Sal, you can describe your relationship with Roland now, and because you guys work closely with developing this material, milling this material. So you have all these options, but generally, if you're busy enough and you're productive enough, you get to the point where you want milling machines for specific purposes. Like big labs, they don't use one milling machine to mill all materials. They have different rooms, and one room is devoted to just milling zirconia. One room's devoted to just using glass material. One room's devoted to just milling PMMA or whatever it may be. So depending on your flexibility and functionality, how busy you are, you may want specific machines for specific products. But if you just want a wet milling machine, the Roland one you see displayed below is at 34,000, 10 to 15,000, 25,000 is a range for your scanner. So you can easily do the math on what the cost would
Great. Question regarding the product. How thin can the margin in the Amber Mill Direct be without having it chipped? In your experience, how thin have you gone, Doc?
I've taken it down to 200 microns. 300 microns is your best bet. And you know what actually happens is a lot of detail here, but depending on where you got your milling machine, where you got who's programmed it. So some people buy a milling machine and they don't care about how the intricacies and how it's involved. But a lot of the mills won't let you mill a restoration less than 0.3 or zero point 0.4. They have a default setting. So even though I may design it down to, let's say, 100 microns, most mills won't let you try and even mill that. They'll automatically in the software or in the machine, they'll bulk that out for you on purpose. So you don't even know that it's been done. And then sometimes you have a lip to it. So they have because last thing a milling machine wants is ready to chip your restoration. Even the CAD software is notorious for that. And if you ever noticed, you get a restoration back from a lab, and if they weren't paying attention, they may have an overhang of the material. So what's happened is they designed your case, everything's perfectly flush to your margin, and right before they go to mill, an area that was maybe under their minimum thickness setting gets bulked out. And then that gets milled, and they don't know that that happened or they weren't paying attention. And then you try that in the mouth or on the die, and you've got like excess material. So it's built in there by default. Sorry about the tangent. To answer your question directly, I need it to be at least 300 microns. So
Got it. And then in reference to lithium disilicate versus zirconia, earlier you mentioned that you're using more lithium disilicate. Is there a technical reason why you prefer lithium disilicate over zirconia?
yes, very much so. So in my journey when I started, I used feldspathic ceramic the first 5 years of Syracuse. I replaced a ton of those. I used them where they were not indicated, second molar areas, short clinical crowns, or short clinical teeth, so it wasn't thick enough. So I believe it was well over 15 years ago, I got into lithium disilicate. It performed very well for me. Like I said, my own mouth is all lithium disilicate from 15 years ago, 14 years ago, whenever Emax was launched. So I know the material very well, I've handled it really well. I can use non-traditional preps. What happens to me, generally where I need the most thickness is at the occlusal. And if I do a traditional crown prep, that gets to be the thinnest. Whereas if you do these crown lay type of restorations, all of a sudden where used to be the weakest around the occlusal now is the thickest. I can't comfortably, properly, confidently bond to zirconia when I do that. Now, the argument with zirconia is that it's strong enough so you can make it thin across the occlusal, but I just like the fact that I can bond to Emax much better. I mean, when you cut off an Emax restoration, that's not fun. It's just glued into it, just melt into the tube. Whereas zirconia, if you just vibrate a little bit, it's not easy to cut through zirconia, but if you just vibrate it a little bit, you can break that seal and it can pop off a little bit easier than an Emax can. So I've just our lithium disilicates, our amber mill restoration kit. So I've always been a big fan of using glass material. I know zirconia is way more popular, certainly cheaper to get to it, but it's just a matter of preference. I like the way lithium disilicate handles. I've been very comfortable with it for almost 20 years. So it's my material of choice for sure. If I need strength, I'll use gold. Maybe I do 5 to 10 gold restorations, if that, a year. So for me, it's either lithium disilicate or gold restoration. But I know most people prefer to do zirconia. You certainly have that available to you as well. So you just want to be able. Bottom line is, you don't want to say no to a patient. You always act in their best interest. You want to have a bunch of different tools in your belt, as a common cliche that we use, but you want to be prepared for every kind of situation. Zirconias, I just don't bond as well to, but that's changed dramatically. I know people are very comfortable with bonding to zirconia.
And lastly, Doc, because we are nearing the top of the hour here, what has been your experience with the opposing teeth using the Amber Mill Direct product? Do you find that the product, because it's pre-crystallized, creates a condition where the opposing teeth would be a concern, or what's your experience, in those specific scenarios?
So the simple answer is we don't know yet because it hasn't been around. Usually we look for those things. So 5 years down the road, how much wear is there? When did you launch Amber Mill Direct? I have to assume it has the same wear characteristics as Amber Mill, and it's been a non-issue for all these years. Can you give us a timeline? When was Amber Mill launched, and when was Amber Mill Direct launched in the U.S., if you don't mind?
Sure. So Amber Mill was launched in the U.S. approximately 5 to 6 years ago, and the Amber Mill Direct product has been in the U.S. for the last 2 years, but we officially launched this past September. Officially launched only a few months, 3.5 months ago. So you're right. There's not a lot of data yet, but it is our predecessor is the Amber Mill Direct. I'm sorry, the Amber Mill. So in the Amber Mill experience, how do you find the product when it comes to the opposing teeth?
So of course it's anecdotal. I mean, very happy with it, very comfortable with it. It's not an issue at all. But if you have any studies that say differently, please share it with your users. But it's the wear that you get from zirconia to the opposing. It's not existent with lithium disilicate. I'm not concerned at all. Clinically anecdotal. I don't have hard facts to back that up with science.
No problem. What we do have a series of materials that we will share with our attendees that again will give more details specific to the product and also the research that we do have available. We actually have several research papers specific to the products we discussed today, in particular the Amber Mill, since it has been around now for quite a few years. So with that, Dr. Armen, I want to thank you once again, for taking time out of your very, very busy schedule to be here with us. I think you gave an amazing presentation. And once again, for the attendees from all over the world, visit tryambermill.com/DTI. We'll send you the actual product so you could test it out yourself. And we look forward to hearing more from all of you, and have a wonderful day or night, depending on where you are. And with that, I'm going to sign off. And Dr. Armen, have an amazing rest of your Sunday.
Yeah. Thanks very much. Appreciate being hosted.
Take care now.
Very flattered. Thank you, guys.